Tell me when you start.
Yeah, I started.
Do you see my screen?
Yeah.
Yeah.
Yes.
So I just updated the slide to make it polished and final. So Mike was asking me about the progress. So that's why I kind of make it a little bit more professional looking, so that you guys can have it. Maybe because someone will use it, right, going forward. So
Mhm.
just making sure that this is good. So I just wanted to know, included what are in the slides. So as I was looking into the slide, it was not really clear about what this slide is all about, right? So you open a
Mhm.
slide, and if you do not know what it is all about, so then I tried to reshuffle some of the sequences and tried to come up with the flow. So the flow is, of course, what is load forecasting, and then uh, different techniques for model development, and then why do we need dummy predictors, and then how to use expert method for forecast error adjustment, and then finally some additional topics, and then model selection and deployment. So just going to just take you through all of these slides is why do we do load forecasting, and then the next you have types of load forecast, and then you have typical forecasting process, and then you have how does the load time series look like. We covered all of this, and then I think the joining the bridge is how you kind of like model this time series, right? How you kind of come up with a model that can simulate this time series. That's all. This is like the ultimate goal, right? So when you kind of develop a model, in the back of our mind, we have a generative concept. Generative concept meaning that we are developing a model that will generate, that means forecast a signal which will represent the actual process of load demand, right? We're trying to mimic, where by this feature engineering, what we're trying to do essentially is we are mimicking the actual scenario so that the ultimate response or the demand looks like actual. So think about it, right? We are just trying to mimic the physical process of the demand by intelligent feature engineering.
Mm.
So this is what
Mhm.
ultimately time series modeling or forecasting is all about. So generating a model that can come up with numbers, arbitrarily numbers that will resemble the actual signal. So always think about it, right? I think many people when they do machine learning, they forget about this. They forget about what is I am modeling. So people give you a data set, and then you fit a model, and then you predict. But is this what is going on? No, right? What is the ultimate goal? The ultimate goal is to mimic the actual data generation process,
Mm.
so that you are trying to have a pseudo reality of the actual time series, of the actual generating process, because actually hundreds of thousands of components are generating this time series. You do not need to model everyone that is kind of like participating in creating their demand, right? You are not talking to every householder, you are not talking to every industrial customer, you are not talking to utilities, you are not talking to the transmission owner, you are not talking to the generators, you are not talking to anybody, but everyone is involved in the load, right? So all you are doing is basically intelligent feature engineering. You are trying to mimic their behavior, or you're trying to capture the truth in their behavior in your model, so that ultimately when you generate 1 day ahead, 2 day ahead, 3 day ahead forecast that resembles the actual operational reality of the system. So this is kind of philosophical, but that's why we do it. So do always remember. So if someone tells you like what is a model, then you should ask this, you should answer this question by that. So by you will say that by a model, I mean I am trying to capture the operational realities of a system through intelligent feature engineering. This is what a model is all about. People talk about model all the time, but if you ask anybody to define a model, they do not have an answer. Like they talk about model is a mathematical algorithm, model is blah blah blah. No, a model is just a combination of your knowledge and a generative process. It generates some data, it spits out some forecast, and that forecast has relative resemblance to the actual signal that you will see going forward. So always remember this. Even someone who have a PhD, they may not be able to define a model. So what is a time series model, right? A time series model is actually the generating process of the data distribution that is kind of like resembling the original situation. So then we had the ARMA method. We described the ARMA method, right?
Mm.
So then what I did not really tell you is about parametric versus non-parametric. So I'm talking about coefficients, right? Here I'm telling you that yt is a function of psi1 multiplied by yt1 plus psi p plus ytp. So how you estimate psi1 to psi p, right? Theta1 to theta p, how you estimate it? You have to make a matrix and then you invert your matrix and then you get the coefficients, right? So this is parameter estimation. So parameter estimation can be done in many ways. So linear regression, we had estimated the parameter with least square method, right? Ordinary least square method, but it is not the only one method. In time series, if you look into the ARMA process, there are many algorithms to estimate these parameters. All will give you the kind of same result, but there are many ways to do it. So I have inserted a link which will help you, which you can try utilize. Like if you want to build a ARMA model from scratch, how you do it, right? So one of the parameter estimation method is called Ewell-Walker equation. So Ewell-Walker equation is basically like it comes up with, it uses the training data to comes up with a system of equation, and then you solve that system of equation using linear algebra methods, and that's how you can come up with the value of the coefficients. So now I want to ask you, even though you format your data as ARMA process, if you use XGBoost, will it be parametric or non-parametric?
By parametric and non-parametric, what's your meaning? Like definition
Yeah,
wise?
this is what I am meaning. If you are parametric method, if you are using parameter estimation method, then you are essentially calculating the value of psi1 to psi p, right? So this is parametric. By
Like,
non-parametric, I'm meaning
mm,
that although it is a ARMA structure, the model have a ARMA structure, but you do not need, for forecasting, you do not essentially need the value of psi1 to psi p, because you have a tree model, right? Which is non-parametric. The tree model have a decision tree ultimately guiding your decision or prediction, but that decision tree is not parameter, like it is not dependent on any parameter. A decision tree have a structure, right? But ultimately, if you feed a decision tree based regression algorithm and if you feed a parameter based regression algorithm, both will generate numbers, right? The number may not be the same, but both will generate the numbers. So what we are doing at Empowered is that we are taking this ARMA methodology or ARMA mindset. We are generating features using the ARMA methodology, but we are not using parametric estimation method. We are using XGBoost, right? Which is a
non-parametric.
non-parametric regression method. So we are not estimating any coefficient. But for the meta model, we are estimating coefficient, which is a parametric estimation method.
Parametric. Yeah. Alpha 1 and alpha 2.
Yes. So this is, I think I did not really touch upon a couple of days ago. So, I mean, I have, to be honest with you, I have really struggled in the past to understand the differentiation between parametric estimation method and non-parametric method. Both are regression method, but the thing is that it is not really clear, right? So for non-parametric method, you have the tree-based algorithms. They are non-parametric. You are not estimating any coefficient. For parametric method,
There is no coefficients in decision tree, right? Like
no,
alpha
there is
1,
no
alpha
coefficient.
2.
The tree itself is a decision-making policy. So suppose you have hundreds of features. Depending on the value of the feature, the decision tree, you will traverse the tree to ultimately come up.
Differentiate. Makes
So
sense.
the tree structure itself is a knowledge. So that's why decision tree is not necessarily only used for regression or classification. No, many people like especially political science people, they use decision tree to understand people's decision making behavior, right? So ultimately, for a general population, suppose how do people who are first time car buyer, how do they buy a car? So they collect data and they try to fit a decision tree, and they see, so if someone's average income is greater than $20,000, then they look into what is their debt level. Then if their debt level, then if their income is high, more than $20,000, and then their debt or income ratio is maybe more than 5, then they buy a car. So you can build a regression model to do it, right? You have to take your feature like debt ratio, income level, and then you fit a regression model, and then you come up with the logistic regression which will tell you 1 or 0, like buy a car or not buy a car. So this is one method. Another method is to come up with the decision making process itself, which is the decision tree. So what is the parametric one? The logistic regression is the parametric one, because the decision making knowledge is encoded into the coefficient. If you know the value of the coefficient, you can know someone can buy a car or not. But it is not natural, right? Nature does not depend on coefficient. Like, does the sun rotate around the earth on some value of ratio or coefficient? No, right? I mean, physical laws does not really work like that. So the decision tree based method are more natural. It is human mind works like a decision tree. Like if I have, if the time is greater than 1 p.m., I will have my lunch. So human mind works in a tree based method always. So this is non-parametric. So human mind is non-parametric.
So is the non-parametric way always equals to decision tree?
Ultimately, the basic building block of non-parametric method, there are many other algorithms like Gaussian process regression or other things, but tree-based method are more like interpretable, right? Tree-based estimation is really like tree estimation. That's what it is.
Yeah,
And then
Gaussian process regression is non-parametric way of regression, right?
yes,
Yeah, I used that before in my thesis, but didn't
exactly.
totally
These
understood.
are non-parametric. These are non. They will have hyperparameter, but not parameter. So remember, if someone tell you, well, if you are telling that this is non-parametric, then why do have this is a learning rate as a hyperparameter? So hyperparameter is not parameter. Remember, so always have to remember the distinction between two. So neural network is a non-parametric method, but it has lots of hyperparameter, activation function, then it has learning rate, and then blah blah blah, lots of other things. So remember, non-parametric, parametric. Non-parametric estimation is very good. The social science, they always use parametric estimation. Non-parametric estimation is also good. Decision tree based method is really popular here. There is also Gaussian process regression and other optimization techniques which can be called non-parametric method. So ARMA in itself by design is a parametric method. So you can use the ARMA structure, but you cannot call it ARMA model if you are not estimating it, if you are not estimating the parameters. So I will say that, well, my data have an ARMA structure. That's it. But I'm not using ARMA models parameter estimation methodology for my forecasting. I'm using XGBoost, which may have ARMA type structure, but it uses tree-based methods ultimately to come up with the prediction, which is a non-parametric method of knowledge encoding. So I have included a link. It has couple of algorithms. You can see, like my wife took a time series analysis course in her first year of PhD. So they had to build a Yule Walker equation as parameter estimation method from scratch. So that was their assignment. So so usually the courses they give you to build up this algorithm from scratch, but it is already in Python and are lots of already built by lots of hundreds of other people. So you do not need to worry about this. But if you can do it by yourself, if you want to do it, you can do it by yourself. So general exponential smoothing, it is like another regression. It is like Fourier methods, right? So you can estimate your Fourier methods by FFT and then use this FFT terms, format a regression equation, and then come up with a parametric or non-parametric method. It's up to you. So you have to have a fast Fourier transform analysis. If you do not know the frequency already, right? If you do not know the frequency, then you have to do FFT, then come up with the dominant frequency, and then use the dominant frequency to come up with the regression equation. And then either you do parametric or do non-parametric, up to you. So multiple linear regression, I just finally I mentioned here, solve the multiple linear regression using non-parametric approach using XGBoost for better accuracy. That's it. Or you can use the main issue, I think I talked to Habib before. If you use any other algorithm except for tree-based algorithm, you will always have to pre-process your data, which is a very difficult task in itself. You have to do the Z-score transformation and then mean max transformation of all features, not all features, non-categorical features, numeric features, continuous features. So those features you have to mean max or normalization, like z-score normalization, you have to do it, and then you have to fit with some parametric approach, which is by regularization. I'm using lasso, or if you are using L2 normalization, you can use ridge regression, or you want to use L1 L2 together, you can use elastic net. So if you are doing the parametric approach or linear approach, non-linear approach, you can have neural network, XGBoost, and other stuff. So I think now fundamentally I have cleared a lot of other things as well. Like I did not tell you before, right? So then this is dummy predictor. You know why we add dummy predictors. Dummy predictors just increases the fit. So dummy predictors can help you overfit the data, but overfit is better than underfit. You can remove overfitting, but underfitting is meaning that your data is not sufficiently, your model is not sufficiently capturing all the knowledge that is encoded in the dataset. Oh. So yeah, I mean, I just shuffle the sequence of slides so that it kind of becomes a cohesive step-by-step process. So then you have the heuristic method, right? So you also discuss the kernel density estimation. I did not include it here because I did not present it to you formally, but you know it, right? Both of you, kernel density estimation, you can come up with error distribution and then add the median on top of the forecast, and that way you have a more believable forecast. So always remember it. If you want to if you want to do in going forward, you do it. You can send me the you know my email, right? Or you can just send me files to look at. I can look into it and then I can tell you, because tomorrow, by tomorrow, if you can do it, I can look into it. But if you want to do it later, then you can call me, right?
Yeah, I'm more interested to this approach. Like, seems really interesting.
This heuristic method is also fine, but the problem is that you have to read more to kind of come up with this approach, rather than like the KD method. You do not need to know a lot, right? So, but ideas, always have ideas. You can use this cutoff temperatures idea going forward. I think Eugene was trying to use it for PGM. So remember, you have all these ideas. So then finally, you can also, if you want to start from scratch simply, you can have all these simple models and try to increase your accuracy gradually, right? Try to build a simple model and then more complex model and then more. So basically any model you can use all sorts of algorithms, right? For any model, because parametric, non-parametric, whatever. So you can use tools like PyCaret if you structure your data, and then you can use PyCaret to come up with a best algorithm, and then you can use that algorithm and hyperparameter optimization. So going forward, I did not do it because I know XGBoost is a better performing model already. So why do you need it?
Yeah.
So stick to XGBoost, try to learn more about XGBoost. Do not try to overfit the model. I mean, overfit is better than underfit. So do not underfit the model. Give as many features as you want. Reduce features going forward. So have a lot of features and then reduce. I think that's the best way.
I was just wondering, lasso feature detection process or
Hmm.
feature selection process is not correlation based, right? Just making sure, because for the PGA model, we might have to think about a lot of feature selection process
Going forward for what? The uh,
for the PGA model.
model.
Because PGM has a lot of features, right?
Yeah, I mean the main issue is that there is a method called factor analysis. Factor analysis, it finds out, automatically scans out correlated features and replace it with one feature. Suppose you have 100 feature and within 100 feature you have groups of feature that are correlated.
But we
Suppose
need correlation, right? In our case, because as
yeah,
it's like a time series data.
yeah, exactly. No, I mean yeah, exactly. So factor analysis is only applicable to so if you give factor analysis, if you perform factor analysis model on the existing features, it will like take aggregate all this like t minus 1, t minus 2, t minus 3 feature. It will replace all the feature with one feature. So factor analysis is like PCA, right? Principal component analysis. Factor analysis is also available in sklearn. It is called decomposition. So if you look into the decomposition part of scikit-learn, you will find factor analysis, but they are mainly used for causal causal model. So if we want to reduce the feature in time series case, better you can play with the lags. So if you have lags, you can remove the lags, right? Have less lags in the, or if you want to increase the feature, have more lags in that part.
We can
But
what we can do is like we can add more lags to the important cities, like you did in Edmonton and
yeah,
Calgary,
yeah,
and for the small cities we don't need
you
lag,
don't
just
need to have,
average,
yeah.
just one
Yeah.
1 hour lag or something like that,
Yeah,
maybe.
exactly. So this is really important question that you bring up, because you cannot really reduce your feature based on correlation in this part. So time series feature selection, to be honest with you, the literature on time series feature selection is virtually non-existent.
Hmm. Because most of the time series they don't this kind of feature engineering, right? Like normally just
They just
they
add.
add just shift and this is like normal the ARMA method or something like
Yeah.
that. Most of
So
the
you have
time
to,
series.
so what I saw one people do it is find out optimal lags. So they fit a model for, so suppose this is called sequential feature addition. So suppose they create one lag and they fit a regression model and they check the R squared, and then they add two more lags. They check the R square. If it is increased, that means more feature will need it, right? If it is not increased, then they keep only the last one. So
Oh, I forgot. I used this method before. Like
yeah,
taking all first, then measure the mean
yeah. But
square
the
error,
problem is that
then reduce one by one.
then you had all features, but for time series you do not have all features, right? You create feature, so it is like a reverse.
Reverse. Hmm.
So you add one lag and then you fit a regression model, check the R squared, then add another lag, check two features, three features, four features, 100 features. If then you plot the R square, if the R square is where the R square is maximum, you just stop there, right?
Or got saturated.
Yes, exactly. So maximum or saturated, yeah, how you like it. So I can like almost 2 years ago I did this study for another problem for time series price forecasting model. I can look into my old codes, almost 2 year old codes, and find out this function. I think I wrote one. If I will try to see it, but this method, this also has criticism because sometimes it adds unnecessary feature, but you do not have any other option in time series because time series everything is correlated, so you cannot remove feature just because you think it is okay. So that's why I say that machine learning people struggle in in time series, because the thinking process is different. So you have to be very intelligent in feature engineering. If you are just dummy, you are just add lags and have a good model, and it may work out for you. But the more lag you add, the difficult it will be to run to develop a model runner code. If you had all sorts of lags, then it is. I will show you why I say this. Okay, so always think about what are the different other sort of dummy variable you can add to increase the fit. Okay, so we are like by fitting, I mean when you say fit, most of the time that terminology is came from the goodness of fit or parametric approach. Non-parametric approach, it is really difficult to have a fit, like the term fit. Ultimately you have to test, you have to compare the non-parametric method based on the testing data, not the actual goodness of fit. So if you have a parametric approach, linear parametric regression approach, you do not need necessarily a testing data. You can train the model over the whole data set and come up with a goodness of fit test, and then you can say that it is good or not. But for non-parametric approach, tree-based model or any other graph neural network or neural network, you cannot really give people any coefficient. So how you test all the statistical test, you have to go into non-parametric statistical test. So testing the performance on testing data, this is called another type of test. Non-parametric statistics have developed this methodology, cross-validation, k-fold cross-validation, blah, 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 lots of other techniques, because people using non-parametric method, they cannot apply the traditional statistical parametric tests into the non-parametric scenario, right? So that's why they develop their own tests. So I think you have heard about this world test, this test, that test, or like you have to identify which test is for what. So even
Normally
statistical
P test, ANOVA test are for parametric test, right?
parametric only for regression based models. So every parametric statistical test in its heart is a regression. So regression itself, sometimes people call regression testing. Regression itself is a test.
So then why people do cross validation and other thing in linear regression?
Parametric models, how you compare? Yeah, if you do not have a parameter, how you compare the performance?
No, like for parametric too, like
yeah, you do
linear.
not have to be honest, for regression problems, you do not have to. If you are using logistic regression, you do not necessarily need a testing data to check its performance. You only need the testing for hyperparameter selection. But if you are not bothered about hyperparameter selection, if you are happy, if you already know, someone tell you that this is the hyperparameter you are only able to apply, then why you need training testing data split? Right? So if you talk to a economics guy who works with a small data set and you talk to him about training data, testing data, he will look at you and call you crazy, because they already know they are not bothered about any hyperparameter optimization. They're just worried about some simple regression problem, and most of their data set is small. So they cannot really have the luxury of have a trained data set and then perform cross validation and then perform test data set result. No, they do not necessarily do that. They have this method, sold out data set method, but usually if you have a small data set, you have to create more data set by synthetic data generation. Then you can have the ability to test out this. So if you have a small data set, and then your objective is to just causal inference. If you're only interested in doing causal inference, then why you need this machine learning based method, mostly developed for non-parametric or neural networks?
Yeah, got the big picture now.
Yeah, it comes from experience, right? Like everybody tell you a lot of different things, but then you have to look at it and think about it, and then try to connect the dots. Most of the dots really do not connect if you do not think deeply, right?
Makes sense now.
Especially statistical test, they make it like so difficult to
So
understand.
not in case of normal linear regression, there is no hyperparametric tuning. But if it is lasso or reach, then lambda and
Learning rate alpha.
learning rate alpha, then comes hyperparametric tuning, right?
Yes,
And then
Mm.
we need cross validation
exactly.
and things.
So
Makes sense.
that, to be honest with you, sometimes if you just shuffle your data set, you do not need cross validation. If you just shuffle, like reshuffle your data set multiple times, so that every order, so I'm talking about not time series data, I'm talking about static data set where every instance is separate. So you have to shuffle your data set before you start modeling, so that if something has sequential bias, then it removes. You shuffle your data set before, and then you are fine, to be honest. And you
Mm.
can test it out. You do cross validation and you do only shuffling. So you see if your result is only 2% better, then why do you need train test split? So everything has to be tested. Like, so I tell people that do not believe everything people say, even expert. If you believe everything people say, you will go crazy. You have to have your own opinion. If you do not have your own opinion, then how can people trust you as an expert?
Mm.
If you just search and read some paper and then give those references, then people say that, then why do I need you? You do not have any opinion. Why do I hire you? Right? If you cannot develop independent thinking, you are just not better, to be honest. You have to think about it. You have to have your own opinion, even if the opinion is maybe sometime not right, but you have to have your own opinion. But to have opinion, you have to think about it deeply. Your thinking can be wrong, but because you are thinking, then it becomes valuable, right?
Mm.
You have to talk less and think more if you want to develop this expertise. This is the main issue, and sometimes it does not work out, right? Because you cannot really you cannot really like only think and not talk, right? So there are issues. So okay, so let's not talk about it. So just other information that we already discussed. So you already know this. And any questions? Do you think anything can be added in this slide, or it is complete, or at least have a comprehensive manner? Everything is covered comprehensively
Mm.
for forecasting, or at least start forecasting.
I think it's good. Like to get what are the things one might need to start modeling
Mhm.
and something. Not like it's not that someone will read these and understand all of those, but he knows what is to be learned and what can be searched in the internet and what from where to start, something like that.
Yes.
Exactly. This is more for like the new person who will be joining a team.
Yeah.
Yeah, I mean, maybe does not necessarily have any forecasting experience, right? But they know everything, but they have not just touched forecasting for as a
Mhm.
professional problem solving yet. So that's the perspective. So you guys, you, I think for you the most important thing is thinking something and then translating it into a feature. That's the most important thing.
Mm.
Like, can it be helpful in my model? So you have to read, of course, read a lot. The more you read, I think you already read a lot, because PGM report, New York report, all sorts of reports you have built. So try to extract that knowledge and see if something can be valuable in my predictive model. And the most of the ideas you can already get it from the load forecasting manual of every market. You can get all sorts of ideas from there.
Hmm. Yeah, right. Makes sense.
Yeah.
Mm.
And trust your judgment rather than model's performance, because models are just as good as the data set. So if the data set is wrong, then everything is wrong.
Mm.
So most important skill is building the data set, because lots of thinking will be going into develop this data set. By data set, I'm meaning training data, not just the extracting data from energy stream. This is not the data set I'm talking about. I'm talking about how you add these features into the data set. So for PJM, you have to come up with different list of holidays, which is respective for US, right?
Mhm.
You cannot use Alberta's holidays as a holiday feature in PJM. So for PJM, then you also have to like I would say add lots of weather stations that are dispersed across PJM's territory, right? So you from where you can get this information? You can get this information from the 5 CP contribution, right? Which zone have more contribution in the peak load?
Mhm.
So give more weight to that that zones data. And you know most of the feature you can find it out from the Alberta. So the day of year, Monday, Sunday, you know, that feature, and then holiday. Then you can add COVID feature as well. But COVID, the training data that you will have does not necessarily have COVID impact there.
Mhm.
Weather features, different weather features. Try only with temperature first. Do not add wind first. Just try it out with temperature. Let's see what happens, right? And then add solar radiation. I think this is important for PGM especially.
Mhm.
So solar radiation forecast, I think you get from WWO as well, right?
Mm. Yeah, solar radiation.
Solar radiation forecast. So you can add that solar radiation forecast in there. So there is not a lot of features, to be honest with you. Nothing really. Past load, day, month, year feature, then holiday feature, then weather feature. So you can start almost immediately. So you can start building data. You already have a data set, right? Eugene build the non weather and Habib build the weather. So you already have a data set. So now what you need to do is basically remove features, remove unrelated location features, and then start building the
We
model.
have overlapping. When I was like looking deep, I found that we have overlapping weather data in our training set for PGM.
Okay, so you have to remove the overlaps first,
Because
right?
I added 19 airport weather data, and the cities, all the cities that Eugene collected, those have the same as the weather, because those cities are collecting data from those weather stations. So
Mhm.
the cities and the weather station data are basically same, so they are not adding any
Adding
values.
anything to the model. Yeah.
Yeah,
They
so
will
you
just
might have
create
to
additional
build.
complexity.
Hmm.
So yeah, I mean, you can just start building the model after removing this duplicacy, right?
Hmm. Yeah.
Uh,
I have some couple of questions about the version 2 of the model.
yeah.
Uh, so in that folder, I didn't see any database file or
Database.
anything.
No,
So
I did not create the database for it. So
oh,
you
okay.
can just add, you can just copy the code from the version 1 to create the database.
Hmm.
Uh, and you can also use the AILDB and WeatherDB from the version 1 because database is database, right?
Hmm.
Mhm.
You do not need separate database for it.
Hmm.
You have to just take the code and then apply because AIL data, how many version you have, all will have same data source, right?
Same
So
data
this
source.
AILDB and WeatherDB will be same.
Hmm. Just have to filter for
Yeah,
the.
just have to, so you can import the database and then remove the unimportant rows. That's it. You can do it. So that's why I didn't really do it because I know that the same data source will be for all the versions. You will have same data source, and this database is there. So you can keep uploading this database and then take the data as you want. So you can change the query. Suppose you want to select not all from the table. You have to select specific columns
Specific
from the
columns
table.
from
Mhm.
the table. Hmm. Yeah.
That's it.
And
Mhm.
one other thing is, like, when I was running the model runner for the version 2,
Yeah.
I found one thing is, like, the model runner for the forecast, it's taking the we have a start time and end time, right? Like
Yes.
for the 24 hours,
Yeah.
but it's not taking the 24 hours next 24 hours, it's
No,
taking
no, no. It is
this
taking the
day,
whole
each
specific
day.
day. Yeah.
So basically, if you
Mm.
want, like, for example, if you run the model, if you want the forecast for the next day, you have to do it after 12 a.m., something like
Yeah.
that, right?
Yeah. Two after two for the Alberta because there's time shift, right?
After 2. Okay, yeah. So
So
like
at the 11 o'clock local time, you're saying?
Yeah, because you will not get a forecast for you if you're using this model runner, or the way I have written the model runner is basically it will only give you forecast for that
current
specific.
day,
You
current
can
day.
change it if you add the forecast interval series. If you can manipulate that version, that portion of the code, you can
Hmm.
have as many as you
Yeah,
want.
yeah.
Because I have added this forecast index of 24 hours, you can add 24 multiplied by 7, then you can do whole 7 days. But where you start, you can manipulate, right?
Hmm.
If
Yeah.
you want to write the model runner for as when you run, suppose you run 2 p.m. and you want 2 p.m. to 2 p.m., that is not possible at this point in time. It will give you only up to 12 p.m. of that specific day, and the no matter when you run after 2 p.m. I mean, I'm adding the 2 hour time shift of Alberta and Ontario. I'm just because you'll be running the code in Ontario, right? So you
Hmm.
have to run it after 2 p.m. to have a next 24-hour forecast, because the time difference between Ontario and Alberta.
Mm.
So
Hmm.
anytime after 2 p.m. you run the code, it will only give you up to 12 a.m. on that specific day. So if you want to change it for suppose 2 a.m. to 2 a.m., then you have to write the start or end forecast, start and end time stamp accordingly.
Hmm.
Mm.
Yeah. So
Not that.
the software like Dio and Damian, they knows that, right? Like,
Yeah,
uh,
yeah. I have given them the code, I think almost 3 weeks ago, right? They should
hmm.
have. So I don't know what discussion you had with
Oh,
them.
like, we only had a discussion that Damian will need a UTC column of the output forecast file, right? Like your model runner
I was
give you.
surprised, to be honest with you. I was surprised. If you generate the forecast, no matter what programming language you can just use that CSV and write up something using your own language. He's a software engineer, right? So you
He doesn't want to take any hassle, just he wants
Yeah.
that the
He
model
just
will
want one
output
file.
everything,
Yeah.
like the output of the model. He don't want to touch anything on that. He want to be in the same side, like safe side. Just the model
Mm.
will the output will do
yeah,
the
but
UTC
you have
time,
to tell him, right?
local time.
You have to it is a shared responsibility, because you cannot dump responsibility on someone else. You have to, if you are Habib, I tell you, you engage with him that this is the model, this is will do, you know it. You need to ask him that no matter when you run, it will not give you the next 24 hour, it will only give you the forecast for that specific day up to 23rd hour or 24th hour, not more than that.
Hmm.
Does this thinking aligned with their product development? This is your responsibility to ask. But I was surprised is that because these guys are already professional software engineers, you have your CSV file output, and then you can just write up some JavaScript. If you are comfortable in JavaScript, you could just take the data from the CSV and convert it with some datetime library in JavaScript. You can do. He could have do it by himself.
Yeah, because they are
Now
doing a
you
lot
have to
of
use
this,
the
right?
Python
Like,
datetime library, right?
yeah, I already converted it. I'll just. Oh, like, which runner code they are running now? This is it for version
V1
1 or version 2?
version one.
Oh, version 1. They
They
don't
don't
have the
have version
version.
2. Version 2, you will hand them over next week. Hand them over next week.
Oh,
You will run
okay.
it, you will test it, and then you will share it.
Oh, that makes sense. Mhm.
Mm.
Oh, and one more thing is the requirement.txt file. So,
Yeah,
like, it
I
seems a
think
little
I
bit
do
different.
not need to give him anymore. because they already have the requirement file from version 1, right?
Mm-hmm. Yeah, makes sense. No, like for our purpose, like the normal the requirement dot text file that you sent, it's like a little bit different. Like when I was trying to get uh, to like import the text file to the my virtual environment, it was showing problems. And when I opened it, like it seems a little bit different than normal requirement.txt file. I normally is known to me. So like
Yeah,
I
but
was not.
I think it should not really matter. Once the only thing matter what is in there, what is written in that file. So if you have all the versions, suppose what you need in what you need to run this code, everything is written on top of model runner, right? What are the important libraries you need? To be honest with you, you can remove almost all other things if you have that specific libraries, but you do not do that. If you have, if you feel that your requirements.txt will have the same have the same information as what I given you or what I shared with them, you just compare the libraries, right? That's it.
Yeah, something like these, right? Like uh, but like shouldn't be it's a little bit different than this one. I'll show you.
Yeah, it is because I'm using a Mac. That's why.
Oh, okay,
Yeah.
that's the problem. So if I want to use it in my like Windows PC, so I just have to do it manually, like for
Uh, I
there
think,
might be some way. I will search in the
yeah, you
internet.
need to start it. Suppose that is also causing a problem because I was following some guy's tutorial back a little bit ago,
Hmm.
and he recognized that Mac and Windows will have separate format of requirements.txt. So he uploaded
Hmm.
requirements.txt for both format.
Oh, okay.
Yeah. So I think what we need to do is basically, you know, give the Windows format or Mac format, like you have my requirement.txt, which is you can write it down, save it as Mac OS, and then what you generate, you remember give it to Damian and call and mention him. This is Windows.
Okay.
Mm.
Makes sense. Hmm.
So now if I want to use suppose Linux, it would be a little bit different, right? So everything has a little bit difference because Windows and Mac, they're commercial operating systems. So that's why it is good to use Linux, because Linux is open source operating system. So we should have used Linux, but what to do?
Hmm. Understood. Yeah, I think other things are good.
So
Like
yeah, I think you can search online, like if there is any Python library to
there should
convert
be.
requirements text from Mac to Windows. So if you ran the model runner 2, I do not necessarily have to show the demo, right?
I already ran it, so I
Yeah,
think it's good.
it's good. So yeah, I think that's all for today in the final session. Anything else you want to discuss?
We might, we can, we can three meet after like 2 3 months, every 3 months for
Yeah, I
just
mean,
normal
I'm I'm
chat.
I'm 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 in your WhatsApp. So what's the issue? You can just write it there. We can
Mm-hmm.
make plans there, right? So that's why I created the WhatsApp.
Yeah.
It is not an issue. If you face any difficulty, feel free to call me. I will like, if I'm not being able to call right back up, or if I miss the call, I will call you. So you can also throw in message if I do not pick up, that you can mention what specific problem, and then when I'm free, we can have a call and discuss. So it's all about the inertia, right? Because you are feeling that I'm not here and this is a big task, but just spend a week and you find that you are fine.
Mm.
Everything is about inertia, right? The more you do it, the better you get. So
Hmm.
it's just It's just, I would say, the initial fear. So initial fear will be gone if you are doing it modeling continuously. But the main issue is that they are hiring a new people, right? So you have to work. The main issue is to come up with a good dynamic in your team.
Should I stop recording?
Yeah, I think we have covered what we needed to do.